In electrical basics, we are going to discuss the AC waveform and AC circuit theory. So here there is a circuit that has been shown in this picture. You can see Vs is the DC source, and it is causing current I to flow in the circuit, having the resistor RL. RL is load resistance, and the amount of the current that is flowing in the circuit is I, which is equal to V upon R. So V upon R is the fixed current that is flowing in the circuit, and it is not changing with the time. The amount of the current that is flowing is constant, and graphically, if you will show, it is like this. So the line is a straight line along the x-axis with the amount of the current which is equal to V upon R. And as you can see with the time, the amount of the current that is flowing through in the circuit is not changing. That is why it is a DC, and current is constant in such circuits. Now let's proceed to another circuit. Here also the same thing is happening. Unidirectional current is flowing. The current is not changing, in fact. Okay. Let us move to another scenario, uh, which is the case of AC. The AC waveform could be of the following types. The first is the sinusoidal wave, sine wave, which is always varying. It has got a positive half cycle and then negative half cycle, as you are seeing here in the picture. The amplitude is changing constantly with the time, and it is varying sinusoidally. And in second picture, you can see this is a complex wave, neither a square wave nor sinusoidal nor triangular. So it's a complex wave. In the third picture, you can see this is called triangular wave, and on the fourth picture, you can see it is called a square wave. So there could be AC alternating current type of voltage and current curves could be like this: a triangular, sinusoidal, complex, or a square wave. Now they all have got the frequency. That means how many cycles they are completing in 1 second. That is called frequency. So here, for in the Indian scenario, we have got the frequency of 50 hertz. That means 50 complete cycles your wave is completing, right? So here you can see it is positive half cycle, and another followed by a negative half cycle. These two cycles are called one complete cycle. So one complete cycle consists of one positive half cycle and one negative half cycle. That's it in the case of all the types of waves. So frequency is sometimes shown as inverse of a period time period. Time period or periodic time are the same thing. So periodic time is shown by T, and F equal to thus becomes 1 upon T. And if you interchange, T becomes equal to 1 upon F. That's the relationship between time period and the frequency. So this is used sometimes for the calculation of frequency or time period, vice versa. All right. Some of the definitions of the frequency prefixes like kilo, mega, giga, tera. These are the prefixes that are used like kilohertz, megahertz, gigahertz, terahertz. These are the types of the frequency that is used. So what does it mean? In fact, kilohertz, when we say how much time period it means 1 millisecond of time period. Omega means 1 microsecond of the time period. Giga means 1 nanosecond of the time period. And tera means 1 picosecond of the time period. So, as you are seeing in this last column, the time is uh, becoming smaller, smaller and smaller. Like microsecond is more than more than nanosecond. Nanosecond is more than picosecond, and millisecond is this more than this microsecond. So this is the relationship. Now, what is amplitude? Amplitude. Uh, This is the positive peak and this is the negative peak here as it is shown. And at various times you can see the voltage level is different, like 1, 2, 3, 4, has been shown in on the x-axis at different time periods, V1, V2, V3, V4, and so forth. It has been shown. So over the one cycle, if you take the average value is somewhere shown by the blue line or purple line as such, and this is the value. So Vmax is the maximum amplitude it is attaining. Any sine wave or a complex wave is attaining is the maximum value of the voltage that it achieves over the time. Right? Now, how do we calculate the average value? So if you sum up all the values at different times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you divide it by number of sections you have taken, number of periods you have taken, then you get the average value of the voltage or the current, right? Now, there is something called RMS value, root mean square value. Actually, average value is not sufficient to explain the amount of the power. So, we take sometimes uh, uh, for better calculation RMS value, which gives us a better picture of the power consumption. Our average value is not able to give a clear picture or correct picture of the power consumption. That is why root mean square value is better considered to be a value that uh, gives you a clear picture of the power consumption in the circuit. So how do we calculate the RMS value? Like I have shown you in the graph that at different times the voltages are different. Now you have to square them instead of just summing up a straight way all of them. We are not doing that. We are squaring them each value and then summing up and then dividing them by the number of sections, and then taking the square root of all them, all all the sums. Then we get the value of RMS, root mean square value. Root mean square rooted, mean divided by n, squared squared the value, each value of the voltage at different times. So this is how we calculate. In the case of a sine wave, it is 0.707, that is 70% of the maximum amplitude of the AC wave. Okay, and at this time, average value is 63%, 63.7% of the maximum value. So these are the typical values in the case of sine wave. Now there is something called form factor, which is the ratio of RMS value divided by your average value. Ratio of RMS and average values. So you take these two values and then if you compare, so you will get a factor that is a fraction without any unit. So this is just 1.21 1 in the case of sine wave. So this is constant and fixed without any unit. This form factor. This form factor is works very uh, important. Takes part in the calculation of voltage in the case of the transformers or alternators as such. Now we have the crest value, that is the ratio of peak value and RMS value. So if you take the average, this is just Vmax divided by 0.707. Vmax is cancelled out, so it is 1 by 0.707, which happens to be 1.414. So this is again the constant value that is called crest factor. AC waveform number 2, Vrms equal to I into R, and the R value of I is 6, and 6 amperes of current is flowing in a circuit, and 40 ohms of resistance is there in the circuit. Considering these two, Vrms equal to I into R, that is 6 into 40, 240 volts. The average value is described is calculated as follows. Form factor is Vrms by V average, and Vrms by form factor. V average is Vrms by form factor, and 240 by 1.1, 216.2. So this is the average value. RMS value is 240 volt, whereas average value is 216.2, which is less than 240 volt, that you must observe here. And the peak voltage is calculated like this. Peak voltage equal to RMS value into 1.414, and that is equal to 339.4. So this is the maximum amplitude it is achieving. Your sine wave is achieving. It is going up to 339.4 volts and making the peak at that point. So there is a comparison here, sinusoidal waveform comparison. Convert from multiply or by to get the value. So peak value you have to multiply by 2, and which is nothing but square of the square root 2, and peak to peak value you get like this. Peak to peak multiply by 0.5, which is nothing but 1 by 2, and you have to divide by half, basically peak to peak value, to get the peak value. Peak value, if you have to multiply it by 0.707 to get the RMS value. And if you have the peak value and you want to convert it to average value, you will have to multiply it with 0.637 or 2 by pi. Pi happens to be 3.14 here, and that gives you the value of 0.637. Okay, then you have to if you want to convert average to peak value, you will have to multiply by 1.570. If you want to convert from average value to RMS value, you will have to multiply by 1.11. And if you want to convert from RMS to peak value, you will have to multiply RMS value by 1.414. And if you want to convert RMS value to average value, then you can, RMS, you will have to multiply RMS value by 0.91, 0.901, which is nothing but 2 root 2 divided by pi. So these are the conversion formulas that helps you in the calculation. So that's all in this first video, and thank you very much for being with me, and keep tuned with me, and keep watching my YouTube channel, Tech Guru Gautam Prasad, and so keep on suggesting me in your comment that how can you make these videos better. So have a nice day. Thank you very much.